Good morning, students. Today I will discuss some numerical problem based on nernst equation. First numerical: calculate the EMF of the cell at 298 Kelvin. This reaction is given. Here this is the concentration 0.1 molar and chromium concentration is 0.01 molar. Standard reduction potential value of chromium is given, and here iron is also given. Then how will calculate the EMF of a cell? This is the nernst equation. E cell is equal to E naught cell minus 0.059 divided by n log of product by reactant. Here first of all we calculate the E naught cell. E naught cell is equal to E naught cathode minus anode, or you can say that right minus left, or you can say that cathode having reduction and anode having oxidation, means reduction minus oxidation. First of all we find the oxidation and reduction in this reaction. Chromium changes to chromium plus 3, here oxidation takes place. Iron 2 plus changes to iron, here reduction takes place. So E naught cell is equal to E cathode minus E anode, means E reduction minus E oxidation. This is the reduction, means iron undergo reduction, that is minus 0.44 minus sign. After that oxidation is minus 0.74, oxidation of chromium occur, that is minus 0.74, that is equal to 0.30. Putting this value here, after that minus 0.059 divided by n. N is the number of electrons gained. Here chromium changes to chromium plus 3, means loss of 3 electrons. Iron 2 plus changes to iron, means gain of 2 electrons. So first equation is multiply by 2 and second equation is multiply by 3. So 3 to the 6, means 6 electrons are gained. Loss or gain both. The log of product value is, that is 0.01. Square is, means 2 moles are given, square, that divide by reactant concentration of reactant, that is 0.1, and here 3 molecules are given, that is power of 3. After calculating, this is the answer. Now next numerical is the EMF of a cell at 25 degrees Celsius. This cell representation given. Iron changes to iron plus 2, concentration given, that is H positive, concentration given, H2 1 bar pressure, and platinum. Standard electrode potential of iron is given and hydrogen is given. Hydrogen standard reduction potential of hydrogen, that is 0 volt. This reaction is given. So first of all we find out what which shows oxidation and which shows reduction. In this equation iron changes to iron plus 2, it means this shows oxidation involving the loss of 2 electrons. Here H plus ions, that it changes to H2, here the loss of 1 electrons, but it is here the 2 molecule gain of 1 electrons, but here the 2 molecules are given, it is multiplied by 2. So it means the number of electrons exchanged in both the side, that is 2. E naught cell, how will you calculate? Cathode minus anode. On cathode reduction takes place, means hydrogen electrode, that is 0, and oxidation takes place on iron side, that is 0.44. After calculating, putting this value, log of concentration of product, that is 0.01, because this value is 0.01, and here H positive given, so that goes to this side, so that is reactant. Square is here because it is the 2 moles. After calculating, this is the answer. For the reaction 2AgCl plus H2 arrow sign 2Ag plus 2H plus, concentration is given plus 2Cl negative 0.1 molar. Delta Z naught value is given, that is minus 43600 joule. Calculate the EMF of a cell. Log of 10 to the power minus n, that is equal to minus n, that is given. Here delta Z naught value is given, and calculate the EMF we have to calculate. Then apply the formula of Gibbs free energy, that is delta Z naught, that is equal to minus NF E naught cell. Delta Z naught value is given, that is equal to minus 2. Minus 2 is the number of electrons exchanged in the reaction. F is the Faraday, that is 96500 coulomb. Into E naught cell we have to calculate easily after dividing this. Then apply nernst equation, because we have to calculate the EMF of the cell. E is equal to E naught cell minus 0.059 by n log of Kc. Kc is the equilibrium constant. E naught cell we have calculated, that is 0.226 minus 0.059 by n is the number of 2 electrons exchanged. Log of Kc is the concentration of product divided by reactant, but in this equation only product concentration is given but not the reactant concentration. So we have 0.1 square means 2 moles, and 0.1 square, that is also 2 mole. After calculating this value, that is log of 0.1 square into 0.1 square. How will we calculate? Means 1 by 10 into 1 by 10 into 1 by 10 into 1 by 10, means 10 is to power minus 4. This will be 10 is to power minus 4. Minus 4 come on this side, minus sign, minus minus plus 4 log of 10. Log of 10 is equal to 1. After multiplying and divide, that is the answer, 0.344 volt. Now the next numerical, determine the value of K and delta Z naught, means equilibrium constant and Gibbs free energy. This equation is given, E naught cell is given, anti-log of K, that is also given. Log of K is equal to n E naught cell divided by 0.059. Log of K is equal to 2 multiply 1.05 divided by, this value is given, 0.059. Log of K, that is 35.6. How will you calculate the K? We take the anti-log of this 35.6. Then after calculating, that is 3.98 into 10 to the power 35. This anti-log we have to calculate from the anti-log table. Delta Z naught is equal to minus NF E naught cell. N is the number of electrons. Nickel changes into nickel 2 plus after loss of 2 electrons, and silver plus ion that gain 1 electrons and to form a silver ion, but here 2 molecules are present, so it gains only 2 electrons. So number of electrons exchanged both are same, means 2, that is 2. F is the Faraday 96500 into E naught cell value is given 1.05, and after calculating, this is the answer, that is the Gibbs free energy, which have negative sign, means this reaction is spontaneous reaction, feasible reaction, workable reaction. Thank you, students. In these numericals, log table and anti-log table values are given in the exam paper. Thanks.